Welcome to this Hack Club AMA. Just a little bit about him, if you guys don't know. Um, he was selected as a flight director in May of 2022 and certified as an ISS flight director in April of 2023. In addition to ISS supporting real time operations, he has also led a spacewalk and cargo resupply mission to the ISS. He also serves as the lead flight director for all emergency response operations for the ISS. But if you want to take maybe 30 seconds to introduce yourself too, that would be great.
Yeah, hey, I guess good afternoon and good evening for wherever folks are at. Can you hear me all right?
Yes.
Yeah, we can
Perfect.
hear you.
So I am a ISS flight director. I've also served kind of all the human spaceflight programs for ISS. So I work also on the Artemis program. I think folks may have heard that we just named the Artemis 3 crew this past week. Um, Luca is actually a really good friend of mine. So we work closely with the astronauts. And really, the job of a flight director is really to ensure kind of crew safety and vehicle safety for all of our human spaceflight programs at NASA. So ISS and all of the commercial crew vehicles that go to the space station, as well as Artemis. About a little bit about me on like my real long history, and then we can I guess open up to questions. But I actually have a computer science degree from the University of Central Florida. I've like a, was a huge coder in high school. I worked for an internet startup company. I worked for Electronic Arts for a little bit at Tiburon Studio in Orlando, making Madden football and stuff. So I've spent a lot of my early career really being a programmer, and then kind of transitioning to NASA. Was a coder for NASA as well. Built a lot of software that we use kind of for the ground segment for mission control. Mission control ends up being a pretty unique building in the world, right? So we talked to multiple vehicles in space and all the infrastructure required for that, and then transition to really flight control. So flight control and flight directors really are the ground team that support the astronauts in space, right? And so a big part, different objectives for different missions, but the space station basically is this huge laboratory, right? I've got things like DNA sequencers, I've got 3D printers, I've got all this cool stuff on the space station. And the whole point of the space station is so really smart astronauts who have these amazing backgrounds in biology or other sciences and all of these things can do science. And then the ground control piece is really managing what I kind of call the utilities of their home, right? Making sure that they have power, making sure that they have data, communications, right? Making sure that they have heat rejection, and then making sure that they also have all the supplies that you need to outfit kind of this world-class laboratory in low Earth orbit of the space station. And that's pretty similar to what we're doing for Artemis as well. Basically make sure that that vehicle is safe. The crews can obviously react in emergencies. And that's one of my kind of backgrounds too, is working on all the emergency procedures for the space station. But the ground control is really there to serve and make sure that they they basically have everything they need to execute that mission, which is do exploration, go play deeper than any people have gone into space. Artemis 2 obviously went farther and faster than any other humans in the history of mankind. Right, we just did that. That was pretty cool. And then going back and landing on the moon, hopefully here in the next couple of years, which will be pretty astounding. So that's kind of very high level what I do, but I think we can open it up if you have some questions, and then yeah, I'm always happy to answer questions.
Awesome. So yeah, I have two or three questions of my own, and then we'll get started and open up to everybody else. First, most of what teenagers see about flight directors comes from movies about rocket launches and like huge control rooms in Houston. What do flight directors really look at during launches, and how much of your job comes in the months before liftoff?
Yeah, so like most of my job is not sitting in mission control. Um, it's really preparing to sit in mission control in a lot of ways, right? For launches in particular, there's really years of training for. I mean, powered flight for a lot of missions are basically 8.5 minutes. So you do literally years of training for that 8.5 minutes. And for a new vehicle like Artemis, a lot of the training is also the development. And so a lot of what flight control is about is pretty much coming up with the worst case scenario that can happen on a day. What can go wrong? And then really with Ascent, what can I then rapidly do to make the thing that went wrong make sure that my mission isn't impacted. And obviously at the top level, right, if something goes horribly wrong, how do I keep the astronauts safe? But then after that, there are like secondary things that can go wrong that I can still do things that make my mission successful. So just a simple example is I have the SLS rocket has 4 engines on it. On the space shuttle program, which we're using the same engines that we use in the space shuttle, the RS-25s, which are these really high performance rocket engines. And there's a couple of failure modes where they can basically cut off for a lot of reasons. It basically shut down. But I still have those 3 other engines. And so that's not like the crew is safe, right? I'm still doing powered flight and I'm still going up and I'm still putting energy into the system because the whole point of ascent is just put as much delta V into your system so that you can go do whatever mission you want to do, right? And so we look a lot at all of the scenarios and like minute, second by second, really of the 8.5 minutes is if I lose an engine here, can I still make my targets? Basically burn the other 3 engines for a little bit longer because I've got all of this fuel in the rocket, right? And then how do I adjust my trajectory? Because now if I burn longer, I have to kind of hit a different target effectively. Like I'm oversimplifying the old mechanics here, but that's a really good example of where we spent years really developing what our response would be in the scenarios, because it's a likely scenario. It's a possible scenario during ascent, and there's literally hundreds of other failures that can happen during ascent that we talk about. And then what I would say the really unique thing about the flight controllers then is so like trajectory analysis is there's like we're NASA, right? We've got like rocket scientists that can do that all day. Where the flight controller comes in is what about the failures that impact other systems? And so what we really look at, like you can call it system engineering, but what if I had like suddenly I had a leak in the cabin at the same time that I had an engine out? And then you start like layering on top of this multi-dimensional problem, and then what is the right response? And I would say a lot of that work over the course of years is really what we're doing in flight control. And then basically you do all that and then you're doing sims. So every week we have a really high fidelity simulator that can simulate what it looks like from our perspective, looking at telemetries and sending commands, and just honing the skills with a highly integrated team where you've got a propulsion specialist and you've got an environmental control specialist and a communication specialist and a dozen other positions that all have to work in concert with each other. And then the flight director is kind of, we talk about like the conductor of an orchestra that is bringing all of that together to make sure that we make the right decision during ascent. And again, keep the crew safe and then try to accomplish the mission.
Gotcha. That's awesome. And then also, my next question is kind of hand in hand with that. You've had a career at NASA about as long as I've been alive, and I'm sure that comes with like thousands, right, of flight simulations and so many cool stories. In the past 17 years, what has been the most interesting scenario you've had to test or train others or yourself for in those simulations?
That's a good question. That's a really good question. I like that question. I think one of the most unique, a lot of our time then ends up being basically responding to failures is kind of our war stories. We talk to old veterans of wars, they'll talk about war stories. We have war stories where things have failed, right? For this space station, we talked about emergencies. There's kind of 3 big emergencies that can happen on a space station. You can have a rapid depress, basically lose air, which everyone, we've seen movies, so we know what that looks like. You can have a fire in space, that's really bad too. And those, I think you can kind of visualize what they would look like, and they're not good. The other one that we can have is called a toxic atmosphere, where basically all the breathable air in the space station suddenly is not good. And in 2014, there was, and then on the space station, just a little bit of architecture. So we have thermal control systems. We basically have water loops inside that are doing heat rejection, right? So they're going past avionics equipment, computers, all sorts of things that get hot, and then sending that warm water to a heat exchanger that then transfers the heat to an outside thermal control system that then radiates it off of radiators on the space station. If you look at the space station, you see these big white things, those are the radiators. The inside coolant, basically the system side is water. Makes sense, right? I heat up the water, I can heat reject it out there. The outside is pure ammonia, which is an incredibly corrosive, toxic element that is bad and will kill you. And so the heat exchanger is a pretty robustly engineered design. But one thing that we're worried about is like if you've got a micrometeorite hit it and then I have a puncture and then I can dump ammonia into the cabin, right? So now I've got astronauts inside that I have ammonia in the environment and it's very bad. In 2014, we actually had a computer failure, a very weird computer failure that made it look like we were dumping ammonia into the cabin. So we had flight controllers on the ground basically think we had ammonia in the cabin because I have pumps and all the pumps pressures went up, and the only way that that would happen is if I had ammonia coming inside, right? And so we executed a response, which is basically isolate the crew members. They don all of this kind of equipment, and then we really were trying to figure out like what happened. And in the process of that, one of the things we do is the outside pressure, the outside thermal control lead system has a much higher pressure. It's like 3,000 psi versus 100 psi, and so we depress the outside of the loop. And that turned it out to be a pretty complicated thing to then repressurize that thermal control system, because what it turned into was then this whole risk discussion. It turned out there was no ammonia. It was this computer failure. We figured that out after a few hours. But then repressurizing the outside thermal control system has all sorts of weird physics in space relative to like two-phase ammonia. So I've got ammonia that's both liquid and gas, and it's super cold. And then the heat exchanger I was talking about before, one of the things that we worry about is freezing the water in it, because then that's actually where you would puncture it, right? If you freeze water, it expands when it melts, and then I put a hole in the heat exchanger. And so I've got all this super cold ammonia, and I want to slowly repressurize it. And basically, when I'm down this thermal control system, I'm down like half of the avionics in the space station because I've completely lost the ability to do heat rejection. I'll melt the boxes basically if I don't have the heat rejection. And so that's kind of a long-winded story, but basically the recovery of that system took like 3 or 4 days, and I was working like 12 or 13 hours and at that point I wasn't a flight director. I was in charge of all the avionics equipment. So I was the guy that basically caused the problem because my computer did this weird bit flip thing because of a radiation hit. And then I also was the most impacted because I had to turn off all this computers, all this comm equipment, like it all just got shut down in like the first 8 hours of all of this response. So that was it was a pretty crazy time, but a lot of the training kind of went into that. And again, to that point of what flight control really does is all that integrated system story. So I was standing right next to the thermal control guy. I was the computer and the comm equipment guy, and we were working through, okay, how do I do this? And how do I do that in the right sequence so that everyone's safe and then we can recover the functionality?
Man, that is insane. That's actually crazy. Yeah, it's insane. All right, my last question is: no matter how long you've been in the industry for, I'm sure every day gives you something incredible to be excited about. What is something coming in the future of space travel that makes you excited to continue working at NASA?
I think in the past few months, really just all of the talk about building a moon base is super exciting to me. I love the space station. So I actually grew up watching the space shuttle, and that was one of the coolest things ever. And I really wanted to come to NASA to work on the space shuttle, and then I showed up, and the space shuttle retired. And so I worked on the space station, which I have learned to love. Like I literally have spent 20 years working on the space station, and it's an amazing piece of just technological advancement. And really, what the cool thing about the space station is just this permanent human presence. As long as you guys have been alive, there's always been people up there. For 25 years, we've had people up there. And the idea of basically doing that at the moon is really pretty exciting to me, because that's the whole point. Like, it's one thing to go to like plant flags on the moon like in the 60s. That's really cool and awesome and stuff, but like I am interested in space exploration because I do want us to eventually be a multi-planetary like civilization, right? Like go colonize moon, terraform or Mars, terraform Mars, all that stuff. And the first thing you got to do is get out of low Earth orbit. The distance from the low Earth orbit, which we're like 400 and so kilometers above the surface on the space station, to the moon, where you're looking at a quarter of a million kilometers, like the distances are just amazing. And you have to really make each one of those steps, right? And so that's kind of what I'm super fired up about.
Yeah, agree. That's awesome. All right, I'm gonna start taking questions from everybody else now. So if I call on your name, please unmute, say your name, age, where you're from, and then ask your question. And then, okay, Joshua Pazak. Sorry, I'm so bad.
That was pretty good for the name pronunciation. Hi,
Okay,
Elias. Thanks for thanks for spending your time here. I'm Joshua Pesach. We're gonna just call me Josh. I have a lot of questions, but I think I'll just start with one for now. And I was wondering, are any of those NASA components that you were talking about, like ground control or anything, are any of those open source? Is there anything that we can maybe take a look at?
Ooh, that's a good question. Um, there's something called the NASA Software Catalog, I think, that's out there. I don't know how open source that is, unfortunately. But there are tools inside of there that we use. So I would say basically our entire infrastructure, like the core guts of mission control, probably are not very open source. But there's tools that live on top of it, and one that comes to mind is just Copernicus. If you Google Copernicus, you can probably find like a link to the software catalog, which then should open it up to the rest of the software pieces like NASA Copernicus. That's actually a mission optimization and trajectory system that we use to build the Artemis trajectory. So a lot of what I talked about in terms of the powered flight is really the engine, and that is pretty neat that we released that. Right, that's like has a lot of power behind it in terms of finding optimal orbits. But in terms of a lot of the command and control systems, we do lock a lot of that down from a cybersecurity perspective for obvious reasons. But certainly the NASA catalog is out there, and there's a lot of software in it.
Awesome. Our next question comes from Samuel Dingle. If you want to unmute.
Hi, I'm Samuel. I'm 14 and I'm from Australia. My question is, what inspired you to pursue a career with NASA and how did you decide on flight director in the end?
Thanks, Samuel. Yeah, sorry, I didn't realize that it's an international thing, so I'm sporting my men's national team because USA is going to beat Paraguay tonight. Anyway, what inspired me to join NASA? So space shuttle, I mentioned that before. I actually grew up in Florida, South Florida, but I would drive up and see a lot of space shuttle launches, and that was just. If you've ever seen a rocket launch, I would highly encourage you to find some place that you can see a rocket launch, and they can be difficult. But if you're ever in Florida, SpaceX launches something like every other week, probably more frequently than that. But the space shuttle was just this amazing engineering marvel that I would say inspired me since I was like a very little child, like 5 or 6. After that, I looked at like astronaut, and honestly, I had really bad eyesight. And back then, they're like, if you have bad eyesight, you can't be an astronaut. And I'm like, well, that's kind of sad. And then I saw the movie Apollo 13. Also a fantastic film. It's a little bit old now, so I don't know if you guys have seen it. But really, the story of Apollo 13, where they had one of the oxygen tanks rupture, and then they brought the astronauts home. And really, watching the ground team in that movie is a really one. It's a good illustration of just how we work and solve problems, complicated problems. My own story that I was just telling about thinking about dumping ammonia into the cabin isn't. I mean, it wasn't as perilous to the astronauts, but it certainly had multi days of 14 hours to try to figure out how to get everything operational in the space station. So it has colors of that, right? And I've certainly been part of other experiences like that. And really, it was just the being part of a high performance team that is really sharp, that is doing just really amazing things for humanity, and being able to contribute to that. Like Apollo 13 really crystallized a lot of those thoughts for me. But I would say that when I saw that movie, I was like 12 or 13. Pretty much after that, I told everyone in my family that I'm just going to have to live in Houston when I grow up because that's where mission control is. And then I ended up out here.
That's awesome. Our next question is from KS.
Hi, my nickname is Case, and I'm from Brazil. And my question is, what is a subject that would consider very important for space travel, but not a lot of people know how important it is?
Ooh, that's a really good question. So I, I like to think I've heard this before. Like NASA and going to the moon requires all skills, right? Like obviously, I talk about aero, mechanical engineering, computer science. Like those are kind of no brainers. But biologists and chemists and physicists all have kind of pieces to this, right? But then I mean, I also need like financial folks to like figure out our budgets, and I need lawyers to figure out a lot of the legal pieces. There's really like I would say that NASA employs tens of thousands of people, and we literally probably employ every single discipline that exists out there. And that, I mean, that's a pretty broad statement, but I mean, I think it's very true, right? I've worked with a lot of amazing people across the agency. I think one of the things, like I wouldn't say that a skill that you need, but something that is very important in kind of working at NASA or just like aspiring to work in this kind of field is really having a passion for it. I think that actually is more important, and I would also say like anything you like want to work on generically, having a passion for it, like coupling that, you're just gonna have higher performance, right? Because you're just gonna you're gonna think about it at like you're going to wake up in the middle of the night and have these thoughts and write them down and say that I should go work on that sort of stuff. Like that kind of drive, I think, is almost more important than the skills. In terms of the skills, I would say find the skills that you're interested in because we need all of them. Because if you think about it, like Moonbase, right? I need all sorts of skills that wouldn't necessarily be obvious. One of the things that we're talking about also with the SR1 mission, if you look at that up, is the nuclear propulsion and nuclear reactors in space. Like that's another big area that we haven't done a lot of in terms of exploration, but is coming online, right? But yeah, I would say that there's just a lot of we can use any skill basically.
Awesome. Leo, if you want to say the next one.
Fantastic. Hi. We've got Hunter asking a question. Hunter says, describe the program, or could you describe the program estimated timeline and what each Artemis's flight individual purpose was or will be with Artemis 3 as well?
Yeah. So Artemis 3, for the crew that we just announced, we're looking at launching at the end of next year, so at the end of 2027. And the primary goal of Artemis 3 is going to be testing out a lot of both landers. So we had talked about Artemis 3 being the first landing of the moon, but really, if you look at the Apollo missions, we did a lot of buildup of just testing out, a new human-rated vehicle before we landed on the moon. And so Blue Origin and SpaceX are both building human lander systems, or we call them HLS systems. And so Artemis 3 will go to orbit around the Earth, so we won't actually go to the moon and dock with those vehicles. Like a big part of like docking is a very dynamic kind of activity. You're both traveling over 17,000 miles an hour, and you kind of have to basically look like you're not moving at all relative to each other. So that's been tricky. And so we want to practice all of that before, obviously, the next mission, which will be Artemis 4, which should be about a year later or so in 2028, where we'll land on the moon. And so, in parallel to that, I talk about Moonbase. There's a lot of other companies that are building landers to go to the moon that won't take people, right? That'll land logistics or resources or rovers. We actually are developing a new pressurized rover for the astronauts to drive around, and so they could land habitable kind of volumes too, like the first pieces of the moon base. And so I don't know if we have necessarily a manifest for like what Artemis 5 will specifically do, but Artemis 4 will land on the moon, and then I'll have built up a bunch of equipment at the moon so that I can stay there for longer and I can do more science, and that'll just kind of continue to build out. And that those will all be tied. Again, I've got several commercial companies that have gotten close or have proven that they can land on the moon, which isn't something we have necessarily done for a long time. And so, really, just practicing that, and then seeing what kind of assets we can get out there. And obviously, we're also designing all of those assets already, right? I got a rover in design, and we're starting to build the designs out for the moon-based pieces. And so, it'll really be putting all the infrastructure out there, and then eventually, you'll get to a cadence where the Artemis missions are going to the moon, going to the moon base, staying for a little bit of time, and then coming home.
Awesome. Our next question comes from Jamily House.
Hi, my name is Jamie. I'm from Brazil and I'm 17 years old. So my question is, what was the most terrifying or hard part of your job as being a flight director, or you just get used to solving problem complex solving problems? So.
Yeah, that's a good question too. So as the flight director, I really end up being the person that is kind of the risk decider in real time for the astronauts. And so I don't know if there's ever been a specific time where I have been really afraid, but as I was doing the training, I think there's a lot of reflection, right? Like I end up being the person that, again, if we have a fire or there's a rapid depress on the space station, the astronauts know how to save themselves, but I am definitely part of like how to deal with that and respond properly and make sure that we keep everyone safe. And I think I talked about training for Ascent. One of the things that we also do are just generic sims for the space station. And so a lot of those simulations will end with an emergency. And so, and in the sim,
Oh my gosh, I'm so sorry. You're muted.
no worries. Can you hear me now? So, so we do a lot of simulations where we're really putting the astronauts in a sim in harm's way, like direct harm's way, and we make them more complicated than you'll ever probably see on orbit. And we do a lot to mitigate emergencies so that we never have fires in space, right? Like we don't really fly flammable materials, we don't fly ignition sources, and then we also keep the partial pressure of O2 very low. So we manage the fire triangle, right? We do a lot of things to mitigate that. But in a sim, we just break stuff, and it's how do you react to those things. And so I think a lot, and we do a lot of simulations before I ever sit in real time. And so I think the scariest part is really just working through those and thinking through about what the worst day looks like and how you'll react to that. Because I have certainly thought about that for a long time and never necessarily seen it in real time. And so that was that was probably the biggest thing, especially the mind shift from I was a flight controller before where I was responsible for one system and I was part of the team that kind of managed how we would respond in those cases. Moving to the flight director position, which is it's like no kidding, like I'm the one that has to decide like are we going this way or that way relative to some of the responses.
Awesome. Jesse, 13 from the US, asks, how much manual and hands-on control do you encourage the crew to use during flight versus relying on automated systems? What was your favorite part of the process before launch?
What was the second part? Sorry.
What was your favorite part of the process before launch?
Yeah. So actually, what's kind of interesting for the first part of in terms of manual control is it's been a pretty big evolution. So the space shuttle was like 100% flown by the astronauts. So much so that the ground didn't even do really on any automation pieces. We would tell. I mean, this also makes sense. The space shuttle was built in the 70s, so like it's a little bit old and retired now. But we would tell them to flip this switch or that switch, and they had all the procedures to fly it, like literally fly it home to obviously when it landed after a mission. The space station, we manage a lot of the manual activities from the ground. So water is kind of a good example of that. We don't like water is super heavy, so we don't fly it up there. So I have a closed loop um, water reclamation system basically. So we reclaim like 95% of the water. So the sweat and everything, all of your waste products basically go through a system so that we say that yesterday's coffee is tomorrow's coffee. And that involves a lot of tanks and pumps and just moving water around, moving dirty water around, putting it through the processor to make clean water, moving the clean water around, right? All that's managed from the ground. The astronauts don't really deal with it at all or even think about it, but it is a pretty manual process for the ground. Looking at the vehicles, so you have the SpaceX Dragon, which is a pretty automated vehicle. We use that to, well, we can talk about the Soyuz first. The Russians' vehicle is also from like the 60s, so very manual, but does have an automated docking system, but has a manual backup. Dragon, also very automated, but does have manual controls as well. Manual controls is something that we've put as a requirement for all of the spaceships, basically, to in case the automation fails. And so it's been interesting to see kind of how different companies and the evolution has worked. Right, Orion is probably a little more manual than Dragon, but everything is trending towards kind of a more automated system for good reason. Right, like the processing power of the space shuttle computer, like you probably have to go to a museum to find something as old as that. It's certainly way less capable than anything that you have in your cell phone, and that's just not true anymore. So when you like increase the computing power, right? I have and the sensors. I think sensors is a big thing too. Like you talk about lidar and radar and all these things, especially if you look at like self-driving cars. Like a lot of that tech, we also like trick out our spaceships with those now. And so the technology is just there, where like computer vision also was not around in like the 70s. And so I think the natural evolution makes sense. I think the idea of having a fail safe that you can take over a stick and actually drive it forward and backwards and stuff is also important, right? Because this gets into like mission success. Like even if the software is great, you can still have sensors failures, right? So you could lose your lidar. So you have redundant lidars, but what if you can't do a cross check, or you have other issues with other sensors, right? And so always having that fail safe, I think is important. But there's definitely a lot of reasons to have the automation as well. And then, sorry, I forgot the second part of the question too. Oh, before launch. So yeah, that I mean, I think it's just seeing the team kind of coalesce. So you've been working on something for years, and right before launch, you kind of have seen the pinnacle of all of the training and development, and you've sat in all these meetings talking about things of like, what are you going to do if the engine goes out, and protecting for all these failures. And then, like in the last weeks of launch, you do probably your last couple of simulations, and you really see all like the pinnacle of that work. Obviously, the launch is then like unparalleled amazement in terms of adrenaline, just awesomeness, right? But but really seeing the team come together, and the results of all of that work is really probably what's most amazing about that process.
That's awesome. Um, Skiwiko asks, in physics class, we would often ignore real life constraints like air resistance, internal material resistance, and focus on ideal equations in situations. When you're launching rockets or sending flights, you definitely have to account for things. What are some non obvious constraints or real life factors that you have to account for when you launch?
Well, that's a good question. I think so. Everyone's got different backgrounds, so I'll just talk about what my background has. One interesting thing with the SLS, and actually all rockets end up doing this. The space shuttle really, I think, maybe mastered it, but upper level wind shear. Actually, I'll give you two examples because the atmosphere is kind of funny. Upper level wind shear for a rocket launch actually is more complicated than I would have thought about it going into it. Right? If you have I would have thought the rocket is so like obviously I have loads, right? But I would like design a load such that I can fly into anything. But if I have a bad wind shear at like 30,000 feet, where it just does like a 180, like wind shear basically being a change in the direction of the wind, right? So it's going one direction, and then if it cuts across you, or you're flying basically perpendicular to that wind, that's enough to really mess you up. And so we actually have a whole process that designs the steering commands for the first stage of the SLS to fly into the wind as much as possible, right? Like I don't like I won't turn like I still got to go up and like east or whatever. But I definitely adjust it based on the winds aloft observed. Um, and we do that. I basically led the team to do that, which then turns into a really challenging problem, right? So I have to observe what the winds are, and then I have to build a product that I upload to the vehicle late enough in the count such that I get the steering commands on, and then I have to like make sure that that works because like I don't want to uplink the wrong steering commands for a lot of reasons, right? And then because when the weather changes, right? Then what I end up doing is constantly evaluate what the forecast versus what the actual winds aloft were, and see if the commands that I loaded the vehicle are still valid, or did the prediction was the prediction so far off that now I have this shear that I didn't expect before, and I have to frankly be no go for launch. And I would say and there's a ton of stuff that goes into that too. I'm kind of oversimplifying that, but there's like load indicators on the vehicle that we use a 6-stop simulation to basically tell us are any of the weakest points, because there's probably about a dozen weakest points, being overly stressed based on the actual forecasts of the day. And it's a pretty high fidelity model. It has an aero model inside of it. And so you talk about like you could just assume a frictionless surface or something, right? Make broad statements like that. Like we don't do that in terms of all the analysis. And then although I will say it's still not real, right? Like the simulators have gotten a lot better, but it's like then they're going to put a factor on top of that because there's just certain uncertainties in the system, right? And so I'd say that's another big piece that usually happens in terms of how do I account for reality? Well, usually I put margins on it. It is a lot of what NASA does. I put a 5% margin or 10% margin on it because there's just something in there that I can't 100% model with a high fidelity, a high enough fidelity, such that it's exactly what's going to happen on the day of, right?
Gotcha. Arnav, you have a question? Can you unmute?
Yeah, thank you. So my question is, uh, so how far have you found working with any other astronauts or agencies whilst preparing for your missions? And do you think international cooperation will increase? And like, what could that look like?
Mm-hmm. Yeah, I another big thing. So I'd say I like the space station. One of my favorite things about the space station is the international cooperation. Um, I mentioned Luca. Luca is awesome. I was recently the increment lead for the space station, and so basically for a 4 month tour, I ended up being the flight director that basically provides continuity for the whole mission. So basically it's 24/7 operation. So we have 3 shifts a day. You work a 9 hour shift as a flight director, and then you hand over to the next guy. But to ensure continuity across all of the shifts, there's a lead. So I was the lead, and Luca ended up being my astronaut rep kind of for that time. This is like from November to March, and we talk all the time about obviously our job, but just then also just about kind of the world and life and become friends, right? And I've had just an amazing opportunity to work with all sorts of amazing engineers from around the world. Whether it's the Japanese with JAXA, obviously we've got their astronauts on board, but then also their ground control teams. So we have Houston Mission Control, who's in charge of the U.S. side of the space station, but we work closely with our ESA counterparts who have the Columbus module, which is also on the U.S. side of the space station, and then JAXA has as the GEM module, the Japanese experiment module, and they're in the Scuba Japan and Munich, Germany for ESA, and so we work a lot with those folks, and and really what's kind of fun too is just the different cultural approaches to designing things, and how they think about things, and that's really just given me a huge appreciation for kind of diversity of opinions and thought, right? And that's been really cool to see throughout my entire career. I've worked closely with the Europeans and the Japanese, and then also the Russians. That obviously the Russians a big part of the International Space Station, and they're also think about things differently, right? They solve problems differently than we do, which is great because then like you get the diversity of opinions, so you can kind of move towards this like an optimal solution, right? And just through talking about stuff, you end up learning a lot of stuff. Also, in my career, I got to work with the South Koreans. They have a moon orbiter called KPLO, um, that NASA helped kind of do some of the trajectory design for. And that was another really fun project because they had never done a moon orbiter. Obviously, NASA has a lot of experience with interplanetary stuff, including the moon. And so just helping them design the trajectories for that mission was a lot of fun too. And again, a lot of making friends and just learning about the cultures and how they think about stuff. That that's been hugely important, and one of the most rewarding parts of, again, if I think about like the whole point of NASA is go explore stuff for humanity. That's more than just America, right? That's the whole world. And if you look at things like the Artemis Accords, there's several like almost 100 countries that have signed up on that, right? And so I think going forward, more and more, there'll be ways for international cooperation. There'll be ways for international access to space. I think if you look at the commercial space stations that come after the ISS, there'll be a lot of opportunities for countries that perhaps haven't had astronauts before have astronauts, right? Last year, actually, we had a private astronaut mission go to um, the space station, which had an Indian astronaut, a Hungarian astronaut, and again, just expanding the number of countries that have access to space is, I think, super important.
Awesome. Fridya, do you have a question?
Yeah, so hi, I'm Rudaya, 15 years old, currently live in the UK. I wanted to ask if there was one thing, like opinion of the public about NASA that you would want to change.
Oh, that's a good question. I think the a big one, probably the easy one, is people think NASA is very expensive. NASA is actually pretty expensive. Like we spend like 20 plus $24 billion a year, and that is a lot of money. Um, but in my opinion, that's a good investment for what we do, right? Like, obviously, we have the space station, we have Artemis. We also are developing an X plane, the X-59, to do quieter sonic booms. We have Mars rovers and Mars landers and lunar rovers or lunar landers, right? And lunar orbiting posts. We have Voyager, which is like the farthest human-made satellite ever. I've got orbiter, or I've got probes that are going out to Saturn and Jupiter and Venus and going into the sun. And I do all of these things for $24 billion a year, which is a lot of money. But it's not really a lot of money relative to what we spend on a lot of other things on Earth. And certainly, I'm not like poverty and like human suffering around the world is definitely something that we should all, as like humans, want to try to help fix. But I think exploration is incredibly important for humanity as well. And so that's one thing that I would challenge is like, are we really that expensive? And really think about how important the investment is, right? Because I think again, we as humanity have always been explorers, right? Whether it was Magellan sailing around the Earth, Christopher Columbus, Lewis and Clark, if we're using kind of Americas, but like there's been just a history of exploration for most of the span of human history, and the next big like drive into human exploration is going to be into the stars, and it always has been, and that's just simply going to take investment. Now, I think what's pretty amazing that's happening right now is that investment more and more isn't necessarily just coming from governments. It can come from private sectors. And so I think that's a huge part of it too. So I think that there's like, and you're seeing a lot of that, right? You're seeing billionaires or trillionaires, as Elon Musk apparently was made today, investing a lot of money to do this sort of stuff. And I think that private public partnership is like the way to go do a lot of these things and really supercharge it. But there does need to be that public investment.
Awesome. Kieran?
Hello,
Lucas? Yeah.
hello.
Hey.
Good evening, sir. I am from India, and my name is Akshay. My question is that if you met 16-year-old students who dreams of becoming an astrophysicist and contributing to a future space mission, what specific steps would you recommend them take over next 5 years?
I think kind of back to an earlier point I made. I think really just be passionate and curious is the other piece I would add to that. Um, the technology that exists today to learn things and like just dig into stuff, right? Like between all of the LLMs that are out there and just the internet as like a device, um, you can spend a lot of time learning about a lot of things. And so, astrophysicist or whatever you want to do, I would just be super um, passionate and curious about that what you want to do. So if that's what you want to, if that's your drive, go be the best at that. Go learn as much as you can. Go read papers. Go read preprint papers. Go try to learn what the state of the art is. Um, there's certainly, yeah, there's just a lot of content out there, and a lot of things are moving really fast too, right? I think kind of looking at generationals too. You guys are in kind of a pretty unique generation. I would say that I was in a unique generation too. I grew up before the internet really was a thing, and saw the internet happen kind of as I was going through elementary and middle school. I didn't have a computer until I was like, I don't know, 14 or 13. And then I got the internet. AI, I think, is kind of a similar weirdness, right? And there's a like the internet also has a lot of bad stuff, so like it's not a panacea. Like we have to kind of take it for what it is and not assume that it's something that's going to like solve all the world's problems, but it certainly is changing, I think, how you access information and how you can kind of interact with and learn things, right? And just there's just a lot of interesting things that you can do with that. And I think to that point, then you can leverage that because you're basically native in this environment because you grew up in it, and like you're having all of these kind of youth experiences that are um, kind of ingrained. Much like I'm like a tech native from the internet, and that then I showed up to the workplace, right? I had all these folks that had never used the internet because they're like, I never wanted to use that in the first place, right? So I think there's a lot of potential there, especially in research and development, in how you learn stuff and how we use those tools to really kind of make the next big discoveries. So I think that that's all. I'm obviously a huge fan of technology. Figure out how to use it, be passionate, and continue to be curious about the things that you're interested in.
Awesome. Kieran?
May I ask one more question, please?
No, sorry. We gotta move on to more people. But we will get to you later if we have time.
Hi.
Kieran, if you want to ask yours.
Hi, my name's Kieran Klukas. I'm 18 and I'm from Columbus, Ohio. My question was about siloxanes on the ISS. I was reading an article about them being a problem around 2010 because they were creating carbon spikes in the water supply. I was wondering if that's been an issue that's been fixed or whether that's still an issue.
We are worried about siloxanes. I actually didn't know if it was the carbon spike. What the way that it's been described to me, and this is where my computer science comes out. So we'll. But one of the concerns that we have is we have like our water separators basically degrade when they're exposed to siloxanes, and so that was a concern that we had for a while. That I think we've mitigated internally of the cabin. We don't really have. We basically just embargo them so they don't show up anywhere. Because again, we recycle all the water, so all the sweat, anything, anywhere it comes, right? If it comes into contact with kind of those water separators, you can do damage to them. And then obviously, if I'm trying to reclaim the water separator not working, it's going to cause problems to be able to reclaim the water. And what ends up being a challenge on the space station is there's only so many spares. And then there's spares on orbit, and then there's spares on the ground. And obviously, if they're on the ground, then I have to take a cargo vehicle to fly them up, and so that just becomes complicated. There's also just a finite number of spares. We don't have like spares in perpetuity or spares on demand, and so that's a challenge for all things on the space station, right? Because it's a unique vehicle with the unique equipment, and so while I have lots of contracts that can go build stuff, if we got in maybe a critical sparing situation, in general, we only have kind of a finite number of spares on the ground.
Thank you. That was really interesting.
Cool. Kashav, if you want to ask your question.
Yes. Hi, I'm Kashav from Pakistan. And I'm sorry if my voice sounds weird. I just woke up. It's 2 a.m.
Good morning.
Anyways, yeah. Anyways, I wanted to ask you a question regarding the leak in the Russian section of the ISS.
Mhm.
So I know the temporary fix was to isolate that area and move the crew, but I'm curious about how that actually works behind the scenes. I mean, when a leak like that does happen, what do the immediate protocols look like for managing the crew and actually solving the problem?
Good. That's a good question. So I would say at a high level, the leak is very, very small. It's almost not even noticeable unless you're looking very closely at our sensors. And so a lot of our response to like a actual air leak where I'm losing like pounds of air per second, that's a different kind of set of procedures. So because this like literally we could leak this air out for weeks and it not really affect the pressure in the ISS by much, if anything. We're usually at like 14.2 at psi. Yeah, 14.2 psi. I think you could go a weeks at this point and maybe be down to like 14.1. And so it's not a huge leak, right? But there are like I talked about the emergency procedures for a rapid depress. We're talking like I'm going to 14.1 and I'm going to be at like 10.2 psi in like an hour. So that's like a real leak that we have. And to talk about the procedures for those, a lot of what we do in like a rapid leak is try to figure out where it is and then isolate that leak because I have hatches basically throughout the space station. It's not too dissimilar from a submarine. If you had a water leak in a submarine, you close the hatch and then it's isolated at that, right? Same thing on the space station. If I had a leak a leak presumably would only impact one module because it was a hole in the side of it, right? And so if I isolate it, then that single module will go down to vacuum. But I have a dozen or so modules on the space station, and so the rest of the space station would be livable. And so to go back to the Russian segment leak, it's actually in a very, very tiny compartment at the back end of the space station. The challenge is that compartment attaches on one side to the resupply vehicles. And so a lot of times we have to go, well, when I have a resupply vehicle, I have to get the supplies out of the vehicle. So I have to open the hatch. And so when we do that, we do close some other hatches basically to protect some of the crew members. What happened last week is somewhat of a disagreement between the Russians and the Americans on kind of next steps, where it wasn't like we disagreed with overall their philosophy, but we just want to talk about it a little more. And so, just to minimize the risk, that's where we put our astronauts in what is known as safe haven. So I have another option where I basically can put astronauts inside of the return vehicles. I always have a return vehicle just from an emergency perspective. If something happened to the space station, I need to get home. So there's always an emergency vehicle there. And so we put the crew members basically in their emergency vehicles during that time.
Right. Thank you.
Yep.
Cool. Reese from the Philippines asks, what's a question nobody ever asked you about Artemis 1 that you wish people would ask? And what would your answer be?
That's a really good question. What do I wish they asked? I don't know. I don't know if I have a good one.
We can come back to it.
Yeah, I would just say I'm a trajectory guy, so I could talk. So I led the trajectory ops for Artemis 1, and so actually I'll say the question I actually answered earlier when I told the story about the wind shear. Like that's kind of a crazy thing that not a lot of people know about, and I never really get to talk about. So that was pretty exciting to talk about because I spent so many hours, like months of my life talking about that because it's a must work function, and it's just it's a nuanced thing that ties in meteorology with rockets with like trajectory design. So that was fun to talk about.
Awesome. Naya, if you want to ask your question.
Hi. Um, I've heard many of the issues that NASA faces on a daily, and many programs have been launched to basically obtain community-made like solutions or inputs, such as like NASA Hunt or Citizen Sciences. I'd like to ask what the biggest issue is that NASA is facing scientifically, and if that issue would benefit positively from receiving help from the rest of the world or community. And additionally, how could the community help other than like for example, the citizen science emailing list? Like, is there a way we could provide input?
Yeah, that's a good question, and I'm going to be woefully inadequate to answer it. So, so my background's all operations. So we operate things in space, and pretty much I operate whatever I'm delivered. I think NASA obviously has a lot of scientific research areas that I'm not as familiar with in terms of like designing the next systems. I know that there are NASA challenges out there that we do a lot of the times, right? And so I think I would just point in the direction of the NASA websites to see if there's any current ongoing challenges, because there certainly are scientific things that we need to go figure out. But unfortunately, I don't have a great answer to that.
Awesome, thank you.
Omar, if you want to ask your question.
Hi, I'm Omar. I'm 16 and I'm from Texas. I was wondering, what do you think the relationship should be between NASA and private companies like Blue Origin and SpaceX for like the benefit of the future of space exploration in your like ideal world?
Yeah, I think we actually have a pretty great relationship with them. I think again, the private public partnerships is really, I think, key to success. Especially because then I can leverage a lot of the private money that's out there to achieve common goals. And so I don't think it's lost on NASA that obviously I have to have return on investment for private companies to go to space. And so I think where NASA tries to go right is there are things that NASA does that just don't turn a profit, right? Like sending a probe to Mars isn't suddenly going to make anyone any money, and we have to continue to do that. But creating a rocket that is cheaper and cheaper to launch obviously has paid dividends for SpaceX, and Blue Origin will have kind of the same deal. And NASA needs access to space, and so I think they bring the launch vehicle, and then we put stuff on the launch vehicle is a great way for this to work. I think looking at the lander programs, there probably is commercial benefits there as well. After the space station, we talk about commercial destinations as well. We're trying to build commercial space stations, because we think there's enough of economy there in terms of science or tourism to basically create an economy that NASA will be a customer of, but isn't the only customer. Because today, right now, we are the only customer of the space station in a lot of ways, right? We pay for most, if not everything, of the space station. There's some privatization of things, but we subsidize a lot. And so I think it's enabling commercial companies, giving them money basically to work into an economy where then they can get other customers. That's probably the ideal benefit that we're not quite at yet, is really create those economies that the other companies can get it, and so then NASA becomes a customer of services. So that then NASA can spend more money on the things that simply don't have any economic benefit, right? Like, again, sending rovers to Mars, the initial moon base. Like, there's a lot of pieces that just aren't going to make a lot of economic sense, and the government has to invest in those.
Thank you.
Awesome. That's super interesting. I think it's like super relevant also with like the expansion of like privatized companies. A common theme I'm seeing with these questions is how AI is used, and you mentioned computer vision earlier. But yeah, like how is space technology changing, like with especially with simulations and stuff, with AI, whether that's like neural nets or like convolution neural networks and that kind of thing.
Yeah. I would say we're trying to figure that out right now. That probably is an area that we need help in, because one, it's moving so quick. Like, the frontier models move out so fast that we're just trying to figure out how to even get one kind of in operations. Again, mostly focused on operations. And I think if you talk about automation, like you talk about like flying automation, but there's a lot of other kind of automation that can happen right now. And right now, just in flight control, again, I talked about the water example, moving the water around. That's a very manual process that I'm using somebody and a calculator to kind of figure out from day to day. That could all be automated. We do a lot of work on building timelines for the space station crew members. We timeline their day down to 6-minute increments, and we're trying to maximize science and all of these other constraints. And that's a really manually intensive process today. And so I think that there's probably, they're not very sexy examples, if you will, but there are examples out there where I think just putting some of the machine learning techniques that are out there and mirroring it to our data. As the government, I have data protection kind of things they have to work through. So I think that's probably some of it. And we are the government, but I think bringing those tools to bear will help automate way more than just flying the vehicle. And then I think that enables really more human capital to go focus on some of the other challenges that NASA has, right? So it's really, I mean, you're kind of seeing this across industries, right? Automate the things that make sense to automate, so that then I can take the person's time and devote it to some other things that are then more strategic or solving harder problems.
Awesome. And then I think we have time for one more question, just from me. What is your favorite thing that you've ever built?
That's a good question. I don't know, man. So I'm a computer scientist that I haven't coded in 20 years, and recently I've started to use Claude, which has been one of the most fun things ever. So I've just been happy to go build websites again. A lot of what I coded was websites. Now I'm gonna think through stuff. I don't know.
Tailwind, or like, what was your favorite framework to use?
I grew up in .NET, so like ASP.NET, C Sharp, IIS. Like, I literally, my first job, I was downloading the beta version of the first .NET. Like, that's how old I am. So you can kind of completely date me. But I think I've built stuff that is like software that's running the space station. So I think that's probably like the cool thing. I have stuff that runs in space. That's, I don't know. It's simple stuff, but things like that's pretty fun.
Great. Thank you so much. We appreciate you so much for like letting us use your time, and the stories that you've told are just incredibly amazing. I know everybody here who has been listening is like incredibly inspired, and there are so many hack lovers that like are making awesome things and want to do things in space, or like recognize how important NASA is. And well, obviously, like, Artemis has been such like a global sensation that kids around the world are getting inspired. So we really appreciate you having or taking the time to be with us today. But yeah, thank you so much. I think that's
awesome. Thanks. I really appreciate it. It was a lot of fun. Have a good weekend, guys.
Thank you.
Thank you so much.
If you got to the end of the AMA, thank you for watching. You can find more about our partnership with NASA this summer by visiting stardance.hackclub.com.